Hello, everyone. Thank you for joining us. My name is Itar Guedi, and I'm a Senior PM Manager in Azure Sentinel.
My name's Ben Nick. I'm also a Senior Program Manager on Azure Sentinel on the hunting team.
Today, we're going to talk about detecting unknown threats with entity behavior analytics in Azure Sentinel. With the increasing volume of digital state and volume of security data, SOC faces various challenges, starting with lack and shortage of staff, which leads to alerts fatigue and that 44% of alerts are never investigated. In addition, increasing attack sophistication, insider threats, and compromised users are still one of the biggest pain points SOC have today. So why and what is entity behavior analytics, referred to as EBA or UEBA? It talks about the ability to build a comprehensive profile of the user and entities across time and peer groups horizon. Which devices the users log on to, which application, from which location or resources the user access, in which hours, and what is the volume and frequency of those activities. By identifying what's normal behavior, we can easily find anomalies, which are activities that deviate from the user profile. Behavior analytics and user profiling is meant to handle the following use cases. Abuse of privileged identities. Identify users with high impact on their environment and profile them accordingly. The second one is compromised user and entity. Attacker will gain access to a user account and start working his way throughout the attack kill chain, which deviates from the user profile. Insider threat and data exfiltration talks about rogue or disgruntled employee who start to collect sensitive information and exfiltrate it outside of the organization. I would like to introduce you to Azure Sentinel Behavior Analytics. Based on many customer stories and feedback, the load of stress of security operation teams, our goal when we approach entity behavior analytics in Azure Sentinel is to keep it simple. Profile user and entities in order to detect behavior anomalies. Perform advanced hunting of complex queries with contextual and behavioral information. Provide SecOps with various entity pages which provide a context and clear timeline for entities' activities, and get instant value with our quick and simple onboarding. Entity behavior analytics help you focus on what's important. Leveraging Microsoft Security Expert, we reduce the amount of raw logs you need to look at. When you ingest 100% of raw logs, only 30% have meaningful security value. We take those events, enrich them, profile user, find anomalies, and map them to relevant MITRE tactics and sub-techniques. Instead of sorting through gravel, Sentinel Entity Behavior Analytics help you focus on the big rocks. Now let's talk a bit about the engine. We take the raw data and enrich it with various stuff. First is user resolution. We resolve different user identifiers into one user entity, taking the SID, the SEM account name, the UPN, and merging them all into one AAD user. When we do behavioral profiling, for each activity the user has done, we'll look at three circles. The user itself. Has the user performed this activity in the past? Is it common for him? The user peers. With our pattern peers algorithm, is this activity common for the user peers? And the organizational behavior. Is this activity common in the tenant? We also understand the user potential impact on the organization if he's compromised or his blast radius, and we use host and IP data for correlation. Public IP addresses are resolved into geolocation, and threat intelligence indicators from Microsoft TI services. The output of the EBA engine are anomalies and insights. Let's look at how we enrich the raw data and turn it into anomalies and insights. Here is what we know from the raw data. Here is an example of a 4624 Windows security event. An account was successfully logged on. The user Jeff_L successfully logged on to the finance SRV. This was a logon type 3 and network logon from a public IP address on March 3rd, 2020. This is all the information that the analyst can extract from that specific event. We'll start by adding contextual information. The user Jeff L is in fact Jeff Lederman. This is his email. He is an IT help desk technician. His blast radius or impact on the organization is high, and I can see he was dormant, meaning we haven't seen any activity from him in the last 180 days. Regarding the device, I can see the FQDN of the device, the internal IP address, an indication that this is a high-value asset, and I can see the suspected device owner, which is not Jeff, and from Intune, we can see that the device is unmanaged. From the public IP address, we can resolve the geolocation to China. And from Microsoft TI service, we got an indicator that this is a known botnet network. By seeing the context, the SecOps analysts get a better understanding of what's happening. Now let's add some more behavioral information. In our case, this is the first time Jeff accessed the finance SRV, none of his peers access it, and this is the first time Jeff is connected from China, and no other user in the org is connected from China before. By having the contextual and the behavioral information, the SecOps get a clearer picture of what happened. We've identified an anomaly that Jeff, an IT helpdesk technician, was recently dormant, high impact on the organization, had an unusual access to the finance SRV and HVA from an unusual geolocation, TI indicators of botnet, and we can map it to initial access and lateral movement mind mapping, from raw data to anomalies and insights. Let's investigate entities with Azure Sentinel Behavior Analytics. Azure Sentinel Entity Behavior Analytics also provide out-of-the-box workbooks for guided investigation experience. The first section of the workbooks provide an overview of the number of new or in-progress incidents and how many alerts have been triggered and how many anomalies we've found. Underneath, we have the widget that shows us the top users to investigate by incidents, alerts, and anomalies. Since this session talks about discovering unknown threats, let's focus on users with no incidents or alerts associated with them. Let's start with Jeff, who has only 3 anomalies associated with him. As you can see, Jeff has no open incidents or alerts, but Jeff had 3 anomalies associated with him: anomalous geolocation logon, anomalous account creation, and anomalous role assignment. All of them are mapped to the relevant MITRE tactics and techniques and sub-techniques if applicable, and we provide detailed description on each anomaly and how it is used out in the wild. Clicking on the first anomaly, anomalous geolocation logon, I can see that it is mapped to initial access tactic, and I can pivot to MITRE website to learn more. Scrolling through, we have a column called User Insights, which contains all the information in our Angel profile about the user. We can see that the username is Jeff Lederman. I can see his AAD object ID, his on-prem SID. I can see his blast radius, which is the potential impact he had on the organization. And I can see that Jeff account was dormant up until this activity. Scrolling further, I can see that this was an AAD sign-in activity originated at China via Tor browser. And it got an investigation priority score of 9, meaning highly deviates from the user profile. Clicking on evidence will shed some more light. I can see that this is the first time Jeff has connected from China. This is uncommon for his peers, and this is the first time anyone in the tenant has connected from China. In addition, the usage of Tor browser, which is used for anonymous communication, has never been used by Jeff, his peers, or in the tenant. Jeff has additional 2 anomalies: account creation and role assignment. We can see that those activities were also originated at China, that Jeff created the user John D and then assigned a role to him. Clicking on the evidence tells us that this is the first time Jeff performed this activity. It's uncommon for him and his peers and in the tenant. And keep in mind that we know that Jeff was dormant. And the evidence for the role assignment tells us that this is yet another activity that Jeff never performed before, which doesn't match his peers nor the tenant profile. If we look closely, we can see that the user Jeff created, John D, has also 2 anomalies associated with him. Let's investigate John now. Clicking on John, I can see that there are 2 anomalies associated with him: anomalous login to devices and resource access, both mapped to MITRE tactic of lateral movement. Again, clicking on the anomaly will show me the relevant tactic and further information on how to investigate it. Scrolling further, we can see the user insights again. Clicking on it will provide us the user identifiers and the fact that John blast radius is high and he's a new account in the organization. I can see that John logged on to the terminal server and later performed the resource access to the finance server, which is a high-value asset. Both anomalies got a high score on a scale of 1 to 10, means they deviate from the user, peers, and the tenant profile. Clicking on the evidence, the analyst can quickly see that this is the first time John logged onto this device, and it's uncommon for his peers and the tenant. Same go for the anomalous resource creation. And this is how entity behavior analytics help you detect unknown attacks. It's by taking those low fidelity events, which by themselves doesn't mean much, but an aggregation of them and profiling based on MITRE can provide an indication of compromise. And if the SecOps analyst wants to further investigate the user, he can pivot to the user page, which Ben will tell you all about.
Thank you, Itai. Now I get to tell you about the Entity Behavior Analytics search experience and entity pages. This is the entity search page. You can search for specific user or host entities. The user entities are populated by Azure Active Directory. The host entities are populated by alerts, bookmarks, and the log analytics agent. Let's pretend you are an investigator, and you are assigned to investigate a specific user, Ron Henderson. Now, you could click on Ron's account in the top accounts by number of alerts table, or you could click in the search bar and start typing in Ron's account name. As you begin typing, the autocomplete experience recognizes what account that you're intending and provides it in the results section. You can click on this in order to pivot to the entity page. Note, this is only one entry point to the entity pages. You can get to it from incidents, from investigation, and from the hunting bookmarks. This is the entity page. It pulls together key pieces of information about this user from multiple data sources and puts them in one place. This information accelerates investigation and improves decision-making. On the left-hand side, you can see contextual information pulled from Azure Active Directory to orient the analyst and give them a sense of what they're dealing with. In the center section, you can see a time chart and a timeline showing alerts, activities, and events. The time chart gives you a graphical representation about what's going on in terms of alerts and security-related events. And on the right-hand side, you can click on any of the specific data types to see the individual rows in log analytics. On the alerts and activities section, you can see both alerts, which can be sourced from any number of sources, including Azure ATP, Endpoint Defender, and Azure Defender, and of course, Azure Sentinel's analytics. We also see what we're calling activities. These are aggregations of events, such as network logons, that aren't necessarily alertable, but they are significant for understanding what occurred with this particular user account. In this case, this user logged on to the host DC1 30 times. And in this case, that's a notable event. If I want to drill in and find out more information, I can click on either activity or alert, and I'm taken to log analytics where I can see the raw details and the source of the data. For alerts, I can also click on the incident and be taken to the incidents page where I can see that particular alert in a larger context. On the right side of the screen are what we call insights. Insights provide pertinent details at a glance. This user shows a big spike in failed sign-in events before a steady stream of successful sign-in events. And looking at the table, we can see it's on 7 different hosts. This suggests a successful brute force attack and potential lateral movement to these hosts. Now, if I want to drill in, once again, I can click on the values in the table to get a much more detailed view from log analytics. This is the entity link. You can copy this link and then click on it at a later point to come directly to this entity. This is very useful for sharing the entity with a colleague, putting it into case notes, or into a ticketing system. We also provide the option of allowing you to investigate the entity on the investigation craft. Just click the button on the lower left side of the page. We can see now the Ron Henderson entity in a graphical view. And if I click on this particular entity, I can bring up the information panel. And for any host or user entity in the graph, I'll also see this View Full Details button. This allows me to pivot back to the entity page for any particular user or host account. This brings us back to the user account. Now, let's talk about hosts. Let's say in a hypothetical situation, a very well-informed third party tells you that they've seen an IP address beaconing out to an attacker-controlled C2 node. Now, they give you the IP address of the endpoint on your network, but they don't give you any other details. So how are you supposed to drill in? Well, With the EBA search experience, you're able to type that IP address into the search bar, and you get a short list of hosts to which that IP address has been assigned to over the last 30 days. Additionally, you get information about when that IP address was last seen associated with that host in the log, giving you some idea as to which DHCP lease time allocated that particular IP address to that particular host. As the victim PC has the IP address last, let's start with them. This is the host entity page. It's very similar to the user entity page, but there are a few key differences I'd like to highlight. On the left-hand side, this contextual information is pulled from the log analytics agent. We can see now that this is a Windows 10 machine that's domain joined, and it's been up for at least 30 days based on the heartbeat data. We can also see that it's deployed in Azure, and we can see the specific Azure subscription ID, resource group, and resource name. And we can click on any of those links to get further detail from the Azure portal. Below that, we can see which log sources gave us this particular IP address and when the IP was first seen and last seen allocated to this particular machine. Like the user page, the host page also pulls alerts from multiple sources. In this case, Endpoint Defender tells me that shellcode was contained in a DNS response. Shellcode is often used to exploit vulnerabilities to achieve code execution. Following this alert by about a minute, a malicious PowerShell command was invoked on this machine. Then Azure Defender, a different alert provider, tells me that a fileless attack toolkit was detected. This is followed by an Azure Sentinel analytic that alerts me to potential beaconing behavior. This particular alert is sourced from the common security log, which is populated with firewall data and network infrastructure data from vendors such as Palo Alto or Fortinet. What's interesting is this particular alert only has the public IP address, but because EBA maps IP addresses to hosts, it can show up automatically in this particular timeline. So this machine looks to be definitively owned by a remote administrative toolkit. Now what? Well, now we can take a look at the insights. For insights, we have covered the top items that analysts say they want during an investigation. In the Windows sign-in activity insight, we can see that there's been 5 user accounts that have successfully logged onto this machine. Because this machine is infected with a remote administrative toolkit, these accounts are at high risk for credential theft. So we're going to want to follow up on them. In addition to sign-in activity, we also see Windows process execution for new processes. We can also run baseline analysis on this particular machine and across all machines in the environment to calculate an entropy score and identify process rarity to find the specific processes that are most likely to be anomalous and involved in this particular attack. We can go on to see anomalously high numbers of security events. If you look at the particular graph here, you'll notice it spikes up at the end, which correlates very well with the events and alerts time chart that we saw in the middle of the screen. You can click on any of these particular links to drill into log analytics to see how the insight was calculated and see the raw details from any of the individual events reported. I'd like to direct your attention back to the left-hand side of the screen and scroll down a little bit. Here, we can see that the entity page pulls data from Azure Defender and Endpoint Defender. And not only do we get alert counts and recommendation counts and vulnerability accounts, we can click on any particular metric and pivot directly to that solution's entity page. So if I'm an analyst that prefers to use my EDR solution to drill into my endpoint activity, I can just click on the Endpoint Defender counts, and I'm taken directly to the Endpoint Defender page for that host. And with that, I'm going to pass it back to Itai to talk about advanced hunting.
Thanks, Ben. Hunting over raw data is something Tier 3 analysts and hunters love to do. Now we'll show you how we do that in Azure Sentinel EBA. Sometimes, even simple processes such as seeing if any help desk user with a high impact on the org performed some anomalous resource access are really hard or even impossible to do on raw data. By enriching the data and storing it back into the customer-owned log analytics, hunters can run complex queries with ease. and have contextual and behavioral information embedded in them, where all the heavy lifting of the analytics is done in the engine in the back. Let's see how we can hunt and answer the following hypothesis. We'll go to the logs blade. Under the behavior analytics insights, you can see 4 new tables. We'll focus on the identity info. The identity info table provides a snapshot of the user profile based on their AAD data and the profile learnings the engine has done. Running this simple query, I can get all the user information and use that data to correlate it with other information. The data contain information such as the user identifiers, department, role, title, AAD risk level, and more. Let's look at the behavior analytics table now. This table stores all the enriched data that passes through the EBA engine. For each record, we're enriching it with behavioral and contextual information, which you can find under the user insights, device insights, and activity insights columns. In this example, we can see all the different user insights about Julian. Going back to our hypothesis, show me all the users from the help desk department, which have high impact on the org, who connected to a new resource for the first time, and none of their peers access it. We can now easily create it. We'll just take the relevant user from the identity info table, from the help desk department, and that have a high blast radius. Join that with the behavior analytics table, where the action is resource access, and this is the first time they're accessing that, and it's uncommon for their peers. Making complex queries super easy. Let's run this query now. We can see that we got a hit. Ron is a help desk technician who connected from Israel to the finance SRV, and I can see his blast radius and other user identifiers. And I can see that this is the first time he's accessing that resource. It's uncommon for his peers. And in addition, it's his first time connecting from Israel, and this is the first time we're seeing this connection from Israel in the tenant. So hunting made easy when you're hunting over enriched data. Want to try out yourself? Take action today. Our onboarding process is super quick. Click on the Entity Behavior Analytics in the navigation pane on the left and get started. Select the slider bar in the center of the page to synchronize Azure Active Directory with Azure Sentinel. This action requires a global admin or security admin permissions. Click on Select Data Sources, where you can select which data sources will get enriched in profile. You choose what best fits your organizational specific needs. Listed here are the data sources that are already onboarded to Azure Sentinel that can be onboarded onto Entity Behavior Analytics. We also support EBA on top of security events, but this data sources is not currently onboarded. By clicking on security events, you can go to the corresponding data connector to onboard this data source. You can enable EBA on those events as well. Click and apply will save your selection, and that's it. Next, time to onboard the Entity Behavior Analytics workbook. Just go to the Workbooks blade, under the templates, search for Entity Behavior Analytics, and click Save. Last but not least, start hunting over enriched data. In the Hunting blade, choose Behavior Analytics as the data source to hunt for anomalies based on behavioral profiling. Well, with that, I want to thank you, Ben, and I want to thank you, audience, for attending this session on detecting unknown threats with Entity Behavior Analytics in Azure Sentinel. I hope you find it useful.